Ever pondered why a metal bridge has gaps in it? Or why a glass flask shatters when heated too quickly? These phenomena all boil down to a fundamental concept in physics known as thermal expansivity. Imagine a balmy summer day. The sun is out, and a metal rod is lying in the open, soaking up the sun's heat. As the rod gets warmer, it also gets longer. What's happening here? This is thermal expansion in action, and the measure of how much the rod expands per degree increase in temperature is what we call thermal expansivity. Now, let's delve deeper. Every object is made up of atoms or molecules that are always in motion. When an object is heated, these atoms or molecules move faster and tend to occupy more space, causing the object to expand. Thermal expansivity is a measure of this tendency. There are three types of thermal expansion: linear, area, and volume expansivity. Linear expansivity is the change in length of an object with temperature. It's given by the formula: change in length equals initial length times the linear expansivity times the change in temperature. Next, we have area expansivity. This refers to the change in area of an object with temperature. The formula for this is change in area equals initial area times the area expansivity times the change in temperature. Finally, we have volume expansivity. As the name suggests, this is the change in volume of an object with temperature. The formula for volume expansivity is change in volume equals initial volume times the volume expansivity times the change in temperature. Different materials have different expansivities. For instance, metals typically have high thermal expansivity, which is why a metal rod expands noticeably on a hot day. On the other hand, liquids and gases generally have higher expansivity than solids, which is why a bottle of soda might explode if left in a hot car. Thermal expansivity isn't just a fascinating scientific concept, it has real-world applications too. Engineers take into account thermal expansion when designing structures like bridges or railways. If they didn't, these structures could warp or crack due to changes in temperature. In the world of science, thermal expansivity helps physicists understand the properties of different materials, and it's crucial in the study of thermodynamics. In our everyday lives, understanding thermal expansivity can explain why hot water pipes creak, or why a glass container might crack if it's heated too quickly. In summary, thermal expansivity is a measure of how much an object expands or contracts with temperature change. It comes in three types: linear, area, and volume expansivity, each with its formula. Different materials have different expansivities, and understanding this concept has practical applications in engineering, physics, and our daily lives. So the next time you see a bridge with gaps or hear a hot water pipe creaking, you'll know that it's all thanks to thermal expansivity, the unsung hero of the physical world.